inequalities, it is really almost identical to what we've already done. You get the equation into a zeroed out form and you factor it. But there's more to it than that. And by the way, example 1 says find and graph, which is why I introduced you to the and graph scenario in that old lesson. Okay, find and graph. So they say find and graph the solution set of x squared minus 1 is greater than x plus 5. As much as you'd like to factor this as a difference of squares, you first need to bring this over and zero it out. So you end up with x squared minus x minus 6. If I did my arithmetic correctly, yes I did, hallelujah. Factor it, factors of 6 that have a negative 1 as their sum, x minus 3 and plus 2. Yes, okay. Now, I want you to recognize something. You would say to me, if this was equals, you would say the answer is positive 3 and negative 2, right? Positive 3 and negative 2. So I am going to really quick over here create a graph that has a negative 2 and a positive 3 in it. You don't have to be real fussy about this. This is good enough. And I am going to put an open circle above both of those. Because if you recall, greater thans and less thans are open circles in line graphs, whereas greater than or equal to's and less than or equal to's are closed circles. Now, the only thing that's missing from this right now is the shading, because there's got to be some kind of shading. Greater than, less than, what do we shade? And really, right now, there's no way to know, because I'm looking at this saying, do I shade here, or do I shade maybe the outside? I don't know. But the product of these two binomials is greater than 0, right? In order for a product of two things to be greater than 0, then these two things either both have to be positive, or the result has to be negative, right? Yes. Awesome. So if both of these is positive, it's going to be x minus 3 is greater than 0, or x plus 2 is greater than 0. Why am I saying that? Because in order to have a result larger than 0, this has to both be positive. In contrast, if I have both of them being negative, positive times positive is a positive result greater than 0, in the same way that negative times negative is a positive result greater than 0. So I am creating a scenario where if I multiply this times this, I want both answers to be positive. And that is true right now because I'm telling you this is bigger than 0, which means it's a positive number. And I'm telling you this is greater than 0, which means it's a positive number. That scenario works. Or if the result of x minus 3 and x plus 2, if both of those are less than 0, that means they're both negative numbers. And you know that a negative times a negative will result in a positive value. Positive values are larger than 0. Okay? So I'm going to solve both of these, and I'm going to end up with x is greater than 3. This part's easy. X is greater than negative 2. Okay. Which one of these two solutions would include the other? Let me show you what I mean. If I graph this, negative 2 is here, 3 is here, open circle in that direction, open circle in that direction. Which one of those two values actually scoops in, not includes the other, I'm sorry, can be both? And that's this. This is not greater than 3. Okay? this section is not greater than 3. So the only thing that would be a combined answer here is this. Okay, this is really confusing to think about because remember, whatever the answer is, you have to choose one. You have to choose one of these, and only one of these satisfies both. Numbers greater than 3 indeed are greater than -2. But there are some numbers greater than -2 that are not greater than -3. Therefore, this is going to be your choice. Okay? Either or, you have to choose that. That's the only one that satisfies both. Okay? Over here, you end up with x being less than 3, x being less than -2. I'm going to ask myself the same question, and I like to just graph it because to me it makes it clear. Less than 3, or 3, -2. If I shade, only the -2 satisfies both because some of the things less than -3 are not less than -2. Some of the things less than -3 are not less than -2. Therefore, greater than 3 and less than -2 becomes my answer. As tricky as this logistics was, there is a way to help yourself test to make sure you're right. If I test something in between here and here, every number that falls in between, I'm sorry, should be false. Jeez. Okay, so I'm going to choose 0.
Daniel, change religion, please. Daniel,
0 minus 3 multiplied by 0 plus 2 is greater than 0. Greater than 6. Okay? Do you guys see how I tested one that wasn't shaded? Since it wasn't shaded, that means I did not believe it was true based on what I felt. Okay? I tested 0 and confirmed that 0 is not true, therefore the stuff in between is not true. So I have indeed shaded this correctly. Okay? That's example 1. Example 2, example 3, they don't get any more different than this. They just get perhaps a little more complicated and require a little more time. Example 2. Find and graph. 3t is less than 4 minus t squared. Before you really start thinking about this, let's collect everything so that we have all of our numbers on one side and the 0 on the other. When you can, you always want your squared to be positive. T squared plus 3t minus 4 is greater than 0. Moved everything over. Okay? To factor it, factors of -2, which when added together give you a 3, it looks like it's plus 4 and minus 1. Okay. The product of this and this has to be less than 0. What kind of numbers are less than 0? Positive or negative? Negative. Okay. Okay, negative numbers. The only way you could have a negative product is if one of them is a positive and one of them is a negative. It doesn't matter which one you did first. So this or the inverse. Okay, you have to solve this and make your choice. Solve the other side and make your choice. In other words, in order to keep a negative answer, one must be negative, one must be positive. One must be negative, one must be positive. So I made the 4 negative here, the 4 positive here. I made the one with the 1 positive and made it negative here. So in this answer, I've got t is less than negative 4. T is greater than, lost my place, 1. Less than negative 4, greater than 1. What numbers are less than negative 4 and greater than 1? Are there any? No. There are no numbers. This is automatically no solution because in the real world, there are no numbers that are both of these scenarios. Okay? Whereas in the previous one, one of the two did cover the situation. Okay? No solution. There is nothing that is both this and this. Okay? Doesn't work. Let's do the other side. I've got t plus 4, so t is greater than negative 4. T is less than 1. Okay? Greater than negative 4, less than 1. Looks pretty obvious, but let's graph it. Negative 4, open circle, 1, open circle. Now we have to choose. You might say to yourself, well, I think it's going to be here because it's saying greater than the 4, less than the 1. And you could see that that's right, but before you assume that, I would test something in between. Okay? We believe it's this because this kind of leads us to believe that because both of the numbers came from here. But let's test the 0. If 0 is true, then we're correct. Let's test the 0. Okay, over here. 0 plus 4, actually right there. 0 plus 4 times 0 minus 1. Is that less than 0? Yes. So our answer is correct. Okay, so you can either use a number to test whether you're true or whether you're false, because you know the difference between right and wrong, okay? So I believed it was this because both of the answers came from one side. The other side was automatically thrown out. So I made my open circles. Of course, the book already showed us that this was the answer. I tested the 0 to make sure I was correct, plugging it into the factored polynomial. 4 times negative 1 indeed is negative 4, which is a value less than 0. So we have satisfied our equation, our inequality. What if you've got more than one solution? More than 2 solutions? Like we had 2 numbers there that we graphed. Example 3 has multiple roots or multiple factors. And the way they show you is one way of doing it. I still use the same method that I showed you guys. 9x is less than or equal to x cubed. Blow the 9x over to the right. 0 is less than or equal to x cubed minus 9x. And I like to always put my information on the other side so that it reads something, something, something is less than 0 or something, something, something is greater than 0. So I'm going to just flip this around and say x cubed minus 9x is greater than or equal to 0. Do you see how I just flipped it? So the open mouth is still facing that side. To factor it, I'm going to pull out an x, which gives me x squared minus 9 greater than 0. Difference of squares, x plus 3, x minus 3, all of that with the x greater than or equal to 0. Now I have 3 things I need to solve. Okay? X greater than or equal to 0. That's the first one. This one, if you solve it, x is greater than or equal to negative 3. If you solve that one just as it is, x greater than or equal to positive 3. Now, in order to have a larger than 0 product, they either all, and this has to be positive. The factored, or the product of these 3 numbers has to be positive. So I either have to have two negatives and a positive, or all positive. And that's just too confusing for me. It's just too confusing for me. So here's how I do it. I will take the numbers and I will plot them, the 0, the -3, and the 3. You might like the way the book does it better. -3, -2, -1, 0, and 3. And less than or equal to means they're solid circles. Okay, now the question is, what do I shade? I like to test in between each area. So I'm going to test here to see if that number works. If that number works, then I shade this way. In between here and here, I'm going to test something really small, like a -1, because that's easy in my head to do. If that works, then I'll shade between here and here. From here to here, I'm going to pick another small number, test. If that works, shade. And then I'm going to pick a 4. And if that works, shade. Now the way they're showing you is to graph all of these and plot true or false, whether it's positive or negative, and then identify it using that, but I never liked that way, so that's why I do it this way. So using a -4 to test, I'm going to plug it in right here. -4 multiplied by the sum of -4 and 3, which is what, a -1. Please check my arithmetic. If I'm wrong, please don't hesitate to tell me. -4 minus 3 is a -7. Okay, so that's this test. Negative times a negative is a positive. A positive times a negative is a negative. -28 is greater than or is equal to 0. False. That means this does not satisfy the equation. Okay? -1 is next. Plug it in right here. -1 times -1 plus 3, which is a +2. -1 minus 3, which is a -4. You can probably already see that this is going to be true because two negatives make a positive. 1 times 4 is +4, times 2 is 8. So if this one is true, which it is, because you ended up with 8, then that means everything here is true. If you don't believe me, you can test as many numbers as you want, but that's truth. Okay? That is true. You can look at the book and see that this is not going to be true, but let's test it anyway, just for sake of argument. We're going to use now the 1 in that spot there. 1 times 1 plus 3, which is 4, multiplied by 1 minus 3, which is -2. 4 times -2 is a -8, greater than or equal to 0, false. That means we do not shade anything from here to here. Next one is a 4. 4 we're going to shade, or 4 we're going to check. Checking it by plugging it in. It's easiest to plug it in where it's factored. You could plug it in up here if you want, but I just think it's hard. 4 times 4 plus 3, which is 7, times 4 minus 3 is 1. 28 times 1 is a +28. 28 greater than or equal to 0. It's true. So you are going to shade. So everything greater than 3 works, and numbers between 3 and 1. Okay? So the way you would graph it would look like this, but if you were to write it, they show you there, but you're going to say -3 is less than or equal to, what's the variable? X, which is less than or equal to 0, okay? Or X can be greater than or equal to 3. Okay, this would be the written version of that. Okay? And they're going to say find and graph. So to be completely honest with you, if this is all you give me, technically you've answered the question. Okay? But beware that when you take a compass test, they'll probably have this. They won't ask you to graph because you know it's all fill in the circles on those college tests. Okay? That's it in a nutshell.